Chapter 9, Vocabulary Types. What are the vocabulary types? Vocabulary types basically are just the types that you use in your day-to-day programming. And well, of course, those types include the fundamental types, right? Uh, what are the fundamental types? We've already learned most of them, actually. And some of them we probably didn't. So let's go through this, right? So we have the integral types. So those, int, long, and also the unsigned version and short, right? And then we've got the character types, char, um, char 8, char 16, char 32. And then we'll also have the floating point types, right? You got float, double, long double. And what else? Okay, we have Boolean types, which um, the value can be only true or false. So the Boolean, that's Boolean, or bool. That's the name of the type. And then we have what else are fundamental types? So we have used a null pointer, right? So then there's a null pointer, literal. The null pointer literal is actually is not a um, it has its own type. It's the standard, define its own type as a null pointer type. So null pointer, underscore t. That's the name of the type. So that's also a fundamental type. Then there's another type that when we said, okay, if a function doesn't need to return anything, and the return type would be void. So that void is a type, that simply just indicates you have nothing to return. Now we have not talked about void has another usage there, typically combined with a pointer. You have a pointer to void. That is a sort of a raw pointer that allows some very low level manipulation of a memory. So we don't necessarily introduce that because it's a bit of an advanced topic there. And so again, there's some usage of a void, but void is a special type. That's also a fundamental type. Um, so beyond those fundamental types, of course, we have a bunch of types that we pretty much use, in our programming. For example, we have already introduced a vector. Those are some of the container types. You got a vector, you got an array. We're talking about the standard library array, not the C-style array. And then we also have introduced the smart pointers. You have a unique pointer, shared pointer. Those things are very common, and so we use them. And what else? String, of course, right? So we use string instead of the C-style string, a sort of a char array. Um, we still use string literal, and the string literal still actually is recognized as a null terminated C-style char array. That's a C-style string, but again, that's still fairly common. So that's kind of a. But if you really want a string literal, remember that string type supports a literal suffix that's s. So if you want to, use that is also fine as well. And we're going to learn a couple more vocabulary types, and they're very useful. And there's a reason why we use them, so they're obviously useful. They are relatively new in terms of when it was introduced in the standard, but it really doesn't matter. So they're all here as part of the standard. So first one is optional. When you see this angle bracket here, means it's a template class, template type. The angle bracket, you can put parameters in it. So what's optional? So optional is something that enables you to write clean self-documented function declarations, especially when you have optional parameters or optional return values. And that is actually fairly common. You have sometimes, let's say you're looking for something and you did not find it, and then you have really no valid value to return. And then you can use some special marker or some other special value to return. That's, of course, that's a technique that's fairly common as well. Um, but if you use optional, that's basically more intuitive. It's sort of a standard way of doing it, because then you're saying to the user, your function call function then says, well, this function may not return a value that you want. It's optional, okay, because some condition it did not get the value you need. So in a function declaration that you see this, you may use this optional as a parameter. Now here we actually have a parameter with a default value, default parameter value here, and then so basically this is a no opt is the uh, it's actually a called it this value is a constant. It just indicates um, you don't have a value. Basically, this is a no optional. And then this function returns, this is trying to find the last occurrence of some character that you're trying to find within this string, okay? And so if it did not find it, it will return an optional that's basically has no value. So we can take a look at an example that's also in the book, of course. So this is exactly, so we have this function. We declare the prototype here. So we're going to use in the main function. So we create a string. Now, by the way, this string is not the type, is the name. We'll call the string. Oh, by the way, you wonder, Olga, why can you use string? Isn't that some kind of a keyword? No, string is not a keyword. This is a type in the standard library. This is not a keyword. So that's why you can use it, although it's confusing. Maybe you shouldn't use it. And so this is sort of our target string. We're trying to find some characters. So here we're going to invoke this function, find the last of character A in that string. So obviously it is there, right? You can see it. It just, that when you say find the last occurrence, basically going backward, you're going to see that's the character it'll be found. So the position, this index will be returned. And so, well, it's optional value. So then we'll have to check, does it exist? So you can actually just use this optional object, you put in the if condition, it will be converted to a Boolean. Now, the reason it can be done so, because this type has implemented an operator that allows you to convert, allows the compiler to convert to a Boolean. And so that's really, there's no magic here. That's how it's done. We're going to look at some of those more techniques later on as well. And and so then, okay, now you say, well, there's a value here, and how do you get the value? So this is one way to get the value. And you basically use this sort of dereferencing operator or indirection operator for a pointer. I will say, well, okay, you can use it because this is implemented, this operator is overloaded for this type, but it can be a little confusing. I don't know if I would recommend it because, it can be a little stretch to redefine this indirection operator for this optional object, which is not a pointer. Well, I mean, the semantics is not a pointer, the way it's defined. Um, So, alternatively, you can use this value. You can actually use this value function instead. So you can get the value. Actually, here's an example here. Okay, I guess this is just to showcase what you can do here. So here's an example that you can just use the value function to get the value out of this optional object. Um, so I do like you can just put the object in if, right? It's optional object if. I mean, that is fine. It seems intuitive. But then to retrieve the value, I would prefer, value, although you can use the other one to support it. It just can be a little confusing. And that's that. So, well, not only, you can check this implicitly converted to Boolean or say has a value, you can obviously also compare with the no opt constant. And if you do that, that basically you can do that comparison. There's the same effect to check if you have a value or not. So if it's not equal to the no optional object, then that means you have a value. So that's just the alternative way of doing it. And then in here, it's also demonstrating how you might, for example, remember we have the start index, we have a default value, right? A default value, which is a no option, no optional, which is no value for optional object. So that allows you to say, well, I'm going to specify a default value there. and and again, if your function actually does something like this is saying, if that value is passed in, this let's say when somebody invokes this function, passing the start index, and it will use it. So value, if it has a value, it will use that value, or will provide a default value, which is the last index. And of course, from the function declaration, is not that clear. Probably you want to document it, right? It's probably not a, yeah. And then here, this is just, of course, a simple algorithm basically to look for that character, essentially just looping through that string backward and checking if that is equal to the character you're looking for. Now, a strange thing here, right? You return index, but the return type is actually optional. How is that possible? Well, the compiler will basically convert it to the optional. So this is fine. It's kind of intuitive when you do it this way. You know, you return in the value, which will be wrapped into an optional. Okay. So that's optional. Now, the other thing is string view. Okay, what is a string view? I mean, the name kind of gives it away, what this is about. It has to do with strings. So here's an example here that we may have a function where we want to, find a word in a vector of words, and yeah, that's basically what we're trying to do. What? No, it's not actually. This is not necessarily okay. What this function actually, as we have seen in the program, the example this is actually trying to do is it's trying to parse words out of this text, providing separators. That's the word separators, and then you kind of parse out the words and put that into a vector. Okay. So here insertion of this vector reference is the output parameter for this function. So what can be recommended? What is the whole usage of a string view is that these types on the left, you should prefer using the types on the right. So you see, for example, if you got a pointer to const char, like the C style string, right? If you have literal, that would be that type. And you should consider using string view that is, again, this is going to avoid copy. Even with a const string, like a reference to const string, there's still cases where it will do a copy, including this situation with the C style string, there will be a copy. So with a string view, it will avoid that. So it's kind of an enhancement, but this is dealing with a read-only situation. If you're trying to modify a um, a string, this obviously will not allow you to do so. It's meant for read-only operations. And again, the reference to const string, just the string view would be a very good substitute. It will, again, as we said, this is we just mentioned this. This is going to be avoiding all copying operations of the underlying char array. And of course, there's other flavors of a if when we're dealing with other flavors of characters for Unicode, and then so it's got this wide string UA U16 U32, and then so there's a corresponding view type for those strings as well. So take a look at the example here. So that find words. So this is to parse the words out of a string, and then we have another function that actually will print out the words, like, basically. And what is the situation here? So first, as you see, we passing this again. This is basically a string. We're initializing with a C style string is a string literal, and that we passed into this find words, which takes a string view. And text also, that's from the input, and that's taken as a string view. And so this function actually does the same thing you have seen before, this example before, and this is just showing you can pretty much just do a drop-in replacement of the types that I mentioned here using string view. The one thing you got to remember though is the string view, to make sure the sort of the lifetime of string view does not exceed the underlying string that was because remember we're saying this is not doing copy, and so it's basically pointing to the original string to avoid that copy. So make sure that original string does not outlive uh, well, no, the string view does not outlive the original string. Essentially make sure that whatever it points to is still valid. So that's the little caveat there. Okay. So one thing that's worth mentioning is when you are putting this um, string into this vector of string, this is string view, and so you do need to either you do a conversion to make a string object out of the string view, because the thing with the vector is the vector has to own the objects. So that's why you have to create, you can't just use a string view here. Um, that's basically so again, this type will not be converted automatically, but then will be a conversion though if you use this function in place back. It's like a pushback, except that this is going to construct a a new element based on that type of this. In this case, it would be the string from whatever you're passing as arguments that will be basically constructed or initialized. It's almost equivalent to what you're doing here below. Okay, so this is probably a little shorter in terms of typing, and probably there's more preferred way of doing it. Of course, the string view also has this no position kind of a when you cannot find a valid index, just like the string does. So that it also exists to sort of like a termination condition. So that's the string view. Then another type that you would use, you should be using frequently, is called span. Was the usage of span. Now, remember when we do our function overloading, let's say we have a function called the largest, trying to find the largest element out of a container, say either from a vector or from an array. So here we got a C-style array here. So, and instead of defining two functions, you could potentially combine them into a single one. So if you say, I'm going to use a span, sort of like a little abstraction over what those things are. And then when you use span, then this can actually take whatever you used to pass into this two forms of a functions, overloaded function largest, and now you can just use it as a one form. This reduces duplication, obviously, and this will work just fine. Now, this little, remember, originally those parameters are reference to const, right? Reference to const. So here, the way to deal with that, the equivalent translation is you're gonna take a element type which is a const double, okay? So that will have the same effect, preserving the constantness of the original data. So keep in mind though, the span actually allows you to modify the elements. It just does not allow you to add or remove elements. You can modify them. It implies. Now, so here, this is a list of suggested substitution with span, which it really is an improvement in the sense that this allows you to take multiple forms of containers, including the C-style array. And now with span, you have sort of a generalized your function a little bit more. Instead of overloading too many, now you reduce your overloaded functions quite a bit. Okay. By the way, this notation here, in case you're somehow not familiar with this, the book has explained this. Now T stands for any type, and then so this ampersand in the bracket. If you don't have the bracket, that looks like a uh, essentially that would be a reference, uh, T as the element type of the array. This is actually obviously defining an array as an array type. So when you put this ampersand in parentheses, this is indicating you're actually, this is a type that's actually a reference to an array. It's not an array of references. Okay, so there's a difference here. And let's take a look at an example. Span. So now, so you see the old function prototypes. Let's say you used, without span, you used to have to define. Let's say you got an array here, a const double array, and then you also have a vector of a double here, and right. So then you turn that into excuse me, a span, and this span will basically be able to accommodate both of them. And then here's the other one. Let's say you have a vector of int, a const reference, right? So then you also can change that to span. The span will, it will accept that and more, of course. And then this is also a translation between vector and span. So you substitute vector with a span. So that this way, the benefit of writing a function like this, you're able to accommodate more types instead of a very particular container. You can take multiple containers by doing this way. And now here's one more thing I just want to mention. If you take a look at those three forms of largest functions overloaded, they're still very much looking the same. You see the code implementation is very much the same, right? So can we do better? Yes, we can. And that will be basically the topic of it. I believe the next chapter about the function templates. And so we'll look into that. So this is right now, you can still see there's all pretty much duplication if you see the code. We're dealing with the different types, but it's very much the same code. Okay. So that's all I have to, well, let's actually go to the summary. So just real quick. One is optional. The optional is used to represent any value that may or may not be present. Okay. And then the string view is used to substitute the string, the reference to the const string. Of course, the purpose is to avoid copying string literals or character arrays. And they use span to, as an improvement, reduce your overloaded functions that will be able to accommodate both vectors and arrays and C-style arrays. So that is it's just a nice improvement. You may consider using that. Um, okay, so that's what I have to share about this chapter. Thank you.